Asymptotes. Very, very important one. Asymptote. First of all, what is an asymptote? What is an asymptote? It's called tangent at infinity. Tangent at infinity. Tangent at infinity. So suppose if I have a curve like this, some curve which goes to infinity, y equal to f of x, y equal to f of x, a curve which goes to infinity. Okay. Suppose assume that there is a line, a straight line, something like this. Okay. From a point P, x comma y on the curve, from a point P, x comma y on the curve, I drop a perpendicular onto that line. If I consider the length of that perpendicular from a point P, x comma y onto the straight line, as limit x tends to infinity and limit y tends to infinity, if this length tends to 0, as x tends to infinity and as y tends to infinity, if this perpendicular distance length which tends to 0, suppose, it means that the straight line touches my curve y equal to f of x at infinity, we call such tangents at infinity as asymptotes. Okay, tangents at infinity called asymptotes. Clear? Okay. Now, there are different types of asymptotes. One type of asymptote is a vertical asymptote. A vertical asymptote. When it is a vertical asymptote, now what we have is sometimes the curve looks like this. Somewhere it comes and goes like this, keeps going like this. I don't know where it has come from. Okay, but if suppose this is x equal to a, x equal to a, if I try to find the limit as x tends to a, my function y, as limit x tends to a, y goes to infinity, y goes to infinity, suppose in this case it is plus infinity, then we call x equal to a as a vertical asymptote, which has got slope as infinity, infinite slope asymptotes, which are vertical asymptotes. Okay. Now suppose it goes to infinity this side, so this would have become minus infinity in that case. So as limit x tends to a, it might be y going to plus infinity or y going to minus infinity. Any one of the case might be possible, or both the cases also might be possible, in which case we call x equal to a as a vertical asymptote. Sometimes you can have something like this also. This finding of asymptotes is a very, very crucial aspect in tracing of a curve. Just a curve equation is some function of x comma y is given. Just curve is given. But in order to trace that curve, there are certain aspects which are very, very crucial and important. One of such aspect is your asymptotes. Okay. If you have an asymptote, it clearly means that somewhere it goes to infinity like this. After that, I just need to think of what happens in the finite part. Are you getting? So once at infinity, what happens, if I can understand that, what happens at finite part is becomes very easy for us. It might be passing through origin, or it might be having certain intercepts on x-axis or intercepts on y-axis, something like that. Or maybe tangents at origin, how many tangents are there at origin, all of them I can find it out and trace the curve very easily. So one aspect of tracing a curve is this asymptotes, vertical asymptote suppose. Now let me go a little bit deeper inside this one. Okay. If I look at the curve has got only this one, I don't have this suppose. Then somewhere if you see as limit x tends to a minus y is going to plus infinity. Is it or not? Limit x tends to a minus left hand side of a, limit x tends to a minus y is going to plus infinity. Okay. This is limit x tends to a minus y is going to minus infinity. If I have this aspect also, then only I have curve like this, or else I don't have a curve like this. Is it or not? Now, if I have to have this one, limit extends to a plus, if y is going to plus infinity, then I have this aspect of the curve. Tracing of the curves, these are really crucial elements. Okay, whether I have a curve this side or above or below, do I have asymptotes, a vertical asymptote or not? These are certain things which everyone should know. Okay? Okay. Take this note. Asymptote. A straight line is said to be an asymptote. A straight line is said to be an asymptote of the curve y equal to f of x. Of the curve y equal to f of x. If the perpendicular distance of the point, p x comma y, on the curve from the line p x comma y on the curve from the line tends to 0 when x and y both tend to infinity. అంటే ఈ కేసులోనే మిగతా అన్ని కేసెస్లో x goes to infinity చెప్తాను. Okay, it's only this case that x doesn't go to infinity, x goes to a, therefore we call x equal to a as infinity. Okay, there are two types of asymptotes basically. One is a vertical asymptote, other is oblique asymptotes. Vertical asymptotes means you have slope as infinity. Oblique asymptotes means that slope is finite. Finite means even horizontal asymptote for which the slope equal to 0 also comes as oblique asymptotes only. Okay, which we will discuss later. First take vertical asymptotes. Asymptotes parallel to y-axis. You can take like x equal to a is a vertical asymptote. If limit extends to a minus y equal to plus infinity or minus infinity, and limit extends to a plus y equal to plus infinity or minus infinity. Some infinity, either plus or minus, don't worry about it, because you are not anyway tracing the curve now. In our examination, anyway you are not tracing the curve, don't worry about it whether it is plus infinity or minus infinity. But just think of as limit extends to a, whether y is going to infinity or not. Or if for what values of x, y is going to infinity. If you check them, then you will get vertical asymptotes. Okay? Take a question. Find the vertical asymptotes of y equal to 2x plus 1 by 2x minus 1 whole square into x plus 1 whole cube. 2x minus 1 whole square into x plus 1 whole cube. One thing we can clearly see is as the limit extends to half, y goes to infinity, whatever might be the infinity. Is it or not? Limit extends to half, y goes to infinity. Therefore, x equal to half is a vertical asymptote. Denominator. Okay. Also, limit extends to minus 1, y also is going to infinity. Therefore, x plus 1 equal to 0 is a vertical asymptote again. Note, very important note. Equating to 0. Note, very, very important note. Equating to 0. The coefficient of highest power of y. Equating to 0. the coefficient of highest power of y in an algebraic equation gives vertical asymptotes. The same expression, put it in terms of algebraic, instead of rational function like p by q forms, put it as algebraic one. Algebraic one means y into this entire thing equal to 2x plus 1. Highest power of y, y power 1. Its coefficient, this entire denominator comes as coefficient. Equating to 0 gives vertical asymptote. Any kind of an algebraic expression, consider the highest power of y, take its coefficient, equate to 0, you will get all vertical asymptotes in an algebraic expression only. Okay? For example, xy equal to 1, a rectangular hyperbola. Highest power of y, x, equal to 0, is a vertical asymptote. Y equal to 0, x equal to 0, which is y-axis, is a vertical asymptote. You clearly know that it is something like this. So y-axis is vertical. Similarly, equating the coefficient of highest power of x gives us horizontal asymptotes. Okay, horizontal asymptotes. See, horizontal asymptotes, suppose y equal to c is a horizontal asymptote. Then obviously somewhere or other I have a curve which goes like this. Okay. Now what happens as limit extends to infinity, y is going towards c. As limit x goes towards infinity, y is going towards c. Therefore, y equal to c, we call it as a horizontal asymptote. Right down. Asymptotes parallel to x-axis are called horizontal asymptotes. So what we can add is limit extends to either plus infinity or minus infinity, y is going towards c. If it is minus infinity, that means I have curve like this also. As x going to minus infinity, y is going towards c, means y equal to c is a horizontal asymptotes. That means curve I have like this also. If at all, y going to minus infinity also, so x going to minus infinity also, y going to c means that I have a curve with this side. So tracing of the curve, these are the terms which might be important for us. Okay? Is this okay? Okay? Note. Equating to 0 the coefficient of highest power of x. Equating to 0 the coefficient of highest power of x in an algebraic equation. Gives horizontal asymptotes. Example, y equal to x square by x square plus 1. Y equal to x square by x square plus 1. So if I consider limit extends to infinity, y becomes equal to 1. Therefore, y equal to 1 is what? So what are vertical asymptotes then? X square equal to 0 na. Highest power of y enti. X square plus 1 equal to 0, x equal to plus or minus I, they are imaginary. You cannot have real, we are talking about real plane. So imaginary ones, you cannot call them as real asymptotes. So here one point that you can note is for a algebraic curve of nth degree, For an algebraic curve of nth degree, there may exist maximum of n asymptotes. There may exist maximum of n asymptotes which might be real or imaginary. Which might be real or imaginary. So an nth degree algebraic curve will have n asymptotes, may be real or imaginary. Okay, that's what it means. In fact, in the case of this one, one horizontal asymptote I got, there might be another two asymptotes might be real or imaginary. If they are real, I can find them. If they are not real, they might be imaginary asymptotes. For example, if you have a circle x square plus y square equal to 1, x square plus y square equal to 1 is a second degree algebraic expression which might be having two asymptotes, might be real or imaginary. In fact, it has got two imaginary asymptotes. Ellipse, x square by a square plus y square by b square equal to 1. It has got two imaginary asymptotes. Hyperbola, x square by a square minus y square by b square equal to 1. It has got two real asymptotes. So that's the reason why you are able to draw two asymptotes, cross asymptotes, right?